All right, let's check out question 10 here where we have to integrate this guy, but at the same time give an exact answer. And when I'm looking at him, he's looking like integration by parts because there's no way I can make a u substitution with any of this to get to x squared. So if I take the derivative of sine 3x, that doesn't give me x squared. If I take the derivative of just 3x, that doesn't give me x squared. If I take just the derivative of x squared, that doesn't give me a sine or 3x. So on this one, we're going to have to do some integration by parts. And actually, for this guy, since this is x squared, I think it might be easier to actually work through tabular integration. So what we're going to do is we're going to set up a u side, which would be the x squared, which then becomes derivative of that is 2x, derivative of that is 2, derivative of that is 0. And then on the other side, we would have the dv, which would be sine 3x. So then we integrate that guy. And remember, when you integrate sine of 3x, whatever's inside here, if it's just a 3x like this, you're going to multiply by the reciprocal of the constant, the reciprocal of the coefficient. So if I start, let me write this a little differently here. If this is dv, that would be sine 3x. So if I integrate this, it's going to be 1/3. And then the derivative of what is sine? Well, that would be negative cosine 3x. And then integrate that. And again, we're going to multiply by the 1/3. So that would be 1/9. Negative 1/9 sine 3x. And then integrate that, and it would be negative 1/27 cosine 3x. Not negative this time, it would be positive because the derivative of what is negative sine. All right, so connect these guys. And remember, we're going to connect and multiply by some version of 1, either a positive or negative version. And what we're going to end up with is negative x squared over 3 cosine 3x, okay, plus 2x over 9 sine 3x, plus 2 over 27 cosine 3x, plus c, and this is what y equals, all right? Oh, that's not what y equals. This is not an initial value problem. And we're going to evaluate that from 0 to pi over 2. Okay? So it's just going to be start minus stop. Stop minus start. It's early. Stop minus start. So we're going to start with the pi over 2 part. So negative pi over 2 squared over 3 times the cosine of 3 times pi over 2 plus 2 times pi over 2 over 9 times, that's a nasty 9, times the sine of 3 pi over 2 plus 2 over 27 times the cosine of 3 pi over 2. All right, and that's the first part. And then I'm just going to clean this up real quick. So we're going to end up with a 0 here because the cosine of 3 pi over 2 is 0, and the cosine of 3 pi over 2 is 0. So what I end up with from this row is the 2's cancel. I get pi over 9 times negative 1, all right, which is negative pi over 9. When I put zeros in everywhere, now just look at this real quick. When I put zeros in everywhere, I get 0 here, I get 0 here, and I get nothing in this last spot. So what I'm going to end up with is negative 0 squared over 3 cosine of 0, cosine 3 times 0, plus 2 times 0 over 9 times the sine of 3 times 0 plus 2 over 27 times the cosine of 3 times 0. Okay? And what happens here is when you multiply by 0, all the zeros go away. So all of those guys go away, and I end up with pi over 9 minus, and then the cosine of 0 is 1, so minus 2 over 27. And you know what? I'm okay if you want to leave it that way. That's a pretty good answer. If you want to put it all over one fraction, then it would be negative 3 pi minus 2 over 27, and that would be the same thing. So I'm good with either one of these answers. And that was a fun problem. In tabular integration, here's an instance where tabular integration really can make a difference for our problem. It cleans it up quite a bit, and the integration by parts becomes easier to manipulate.